In this section, we're going to talk about the access control lists. Let's go ahead with the ACL overview. ACL's access lists are a set of commands which are grouped together to filter the packets that enters or leaves to an interface. They control the flow of traffic in network and provide security for network access. Access lists are implemented sequentially as a permit or deny statement to inbound or outbound of interface and used for also different purposes such as, for example, maybe a route map or something like that. There are two types of access lists and they are standard or extended, and they can be used with numbered or named format. Please pay attention that each ACL must have a permit statement because there is an implicit deny rule at the bottom of each ACL. That's the key point. In here you see an example for the numbered access list which are permitting some networks. And here's our configuration, access list and the number, then permit or deny statement, and we are using a network and we are using a field named wildcard, which we are gonna examine later. All access lists must be identified by a name or a number, as I told you in the first slide, and named access lists are more convenient than numbered access lists because you can specify a meaningful name that is easier to remember and associate with a task. You can reorder statements in or add statements to a named access lists, and named access lists support the following features that are not supported by numbered access lists, such as IP options filtering, non-contiguous ports, or TCP flag filtering. Alright, here is how we can configure a named access list. To configure a named access list, we are typing IP access list command, and we are choosing if we are gonna use an extended or if we are gonna use a standard access list most of the time. In this example, we are using standard and IP access list and the standard configuration, and we are writing the name of our access list in here. And as you can see in here, under the access list mode, we are denying or permitting to some statements. Okay, let's go ahead with the wildcard mask term. Wildcard mask is a mask of bits that indicates which parts of an IP address are available for examination and determines what IP addresses should be permitted or denied in access control lists. Wildcard mask has a reverse logic of subnet mask. A 0 in the wildcard mask means to focus to that bit, while a 1 means to ignoring the related bit. If you see a 0 on the subnet mask, on the wildcard mask, that means we need to take care, we need to focus the related bit. But if we are seeing a 1, that means we need to ignore that bit. Okay, I'm going to show you on an example as well. In this access list, we are seeing an access list statement, and this access list is saying us that access list, the number access is 1, permit 172.16.00 with a wildcard mask of 00255. So what that means, here is the network ID and here is the here is the wildcard mask. what I told you is, if we are using a 0, that means we need to focus the related bits. Alright, as you can see in here, I have a 0 and I need to focus to 172. In here, we have another 0 and we need to focus to 16. On the last 2 bits, we have just ones for the 255, as you can see in the binary version, and that means we need to ignore that bit. So this wildcard mask means focus everything starting with the 172.16, and so that means we are permitting everything starting with the 172.16. For example, 100.72.16.1.5, maybe, whatever you want. Let's go ahead with the wildcard mask example 2, and we have another configuration, access list 50, permit, this time 192, 168, 8.0 with a wildcard mask of 000255, which means 80, and here is the wildcard mask, which means we need to focus the first 3 portions and we don't care the last portion because we have continuous ones in here. That means this access list permits everything starting with the 192, 168.8. For example, oh, that's wrong. That's wrong. That would be something like that. And we can give an example like 5, 6, 254, and that's an arbitrary value. Okay, let's go ahead with the standard IPv4 access lists. Standard access lists perform packet filtering based on source address and must be implemented to router which is the closest to the destination address for efficiency. Numbers with 1 to 99 and 1300 and 1999, these ranges are used for standard access list configuration, and these access lists are applied to interfaces by IP access group command. As you can see in here, there is an standard access list configuration. We are getting into the config mode first, then we are typing access list and the number of the access list and the permit or deny and the related network. Then we are getting into the interface mode and we are implementing this access list to our related interface, which means, for example, we have a router in here, we have Fast Ethernet 00 and Fast Ethernet 01, and we are implementing this IP access group to inbound. This would be 50 to inbound, which means we are implementing this access list to this direction. And let's go ahead. In this example, we have another standard access list 4. In the first statement, we are denying the 20. That means everything beginning with this 10, 41, 20 and something like that. The second statement, we are permitting the host 10.41.20.5 in here. Okay, access list rules are implemented sequentially as I told you. In the first statement, we are also denying this IP address, as you can see. So the traffic will be blocked even if we type this IP address with a permit statement in here. As you can see that in here, there's a conflict between two rules in this example. Let's take a look at another configuration example on a topology now. On router 1, we are defining an access list, standard access list, and we are denying the host 2.5. Okay, this guy will be denied. And we are permitting any other traffic. Okay. Then we are getting into the interface mode, interface gig 00, which is here, and we are implementing the access list to inbound. That means in this direction. So PC2 will be denied, for example, if it wants to communicate with the PC1. To edit the standard access list configuration, for example, as you know, access list 1 denying the host 2.6 for this example, which is here, I think. Then access list 1 is permitting we are permitting any other things. So if we want to edit this configuration, we are typing the show access list command, and we are seeing the sequence number in here, as you can see. Sequence number 10 is denying this host, and sequence number 20 is permitting anything else. So if you want to edit it, we are typing IP access list standard 1, then node 10, which means we are deleting this rule, and we are typing again 10 deny host 1041 2.5 maybe. Alright, this is how we edit this. To verify the access list, to verify the standard access list configuration, we can use the show access lists command, and we can also use the show IP interface and the related interface command, and we can see that if there is an inbound or outbound access list applied to that interface. Let's go ahead with the extended IPv4 access lists. Extended access list performs packet filtering based on source address, destination address, protocols, and the port numbers. It's good that extended ACLs are implemented to router which is closest to source address for efficiency. And here is the range that we can use for the extended access lists. Extended access lists are applied to interfaces by IP access group, name, number, in and out statements, as well as in the standard access lists. And here is the configuration example. Access list, this time 100, which is in this range, as you can see, is denying the TCP traffic which is coming from this source and going to this destination for the ports equivalent to 23, which is the telnet port. I can also write this statement in here. Access is 100, deny TCP, same thing, equivalent to, I can write the protocols names as well directly. For example, telnet for this example. Then the same thing as the standard access, I'm getting into the interface mode and I'm typing the IP access group number of the ACL, and inbound or the outbound as the direction. And here is the syntax. As we can see that access list and access list number permit or deny the protocol's name, source address, and the wildcard of the source. Then the port operator and source port and the destination and destination wildcard, port operator, and the destination port again. You'll get it better by this example. In here, as you can see, here we have an access list configuration, which is an extended one. In the first statement, access list 100 is permitting the TCP traffic coming from this network by this wildcard, which means everything beginning with these three portions, and we are permitting this traffic while it's going through this host directly. I can also use in here 10.1.254 with a wildcard mask of 00 instead of here, but I can also use for simplicity host keyword and the host IP address with an equivalent of www port. Okay, that means actually permit TCP traffic from this network to port 80, which is the HTTP port on the host 10, 1, 1, and 204. Okay, let's go ahead with the second. Access is 100 permit IP. This guy is permitting the traffic from this network while it's going through this network. Okay, permit the traffic from this network /24 to that network /24. Okay, let's go ahead with the third. Deny TCPs. Okay, from the host this time again. As you can see that in here where I'm using the 192.168.1.1 with the 0000 wildcard mask, which means actually this IP address. I'm focusing all of these bits, and the destination will be 10.1.1.254, equivalent to 23 port, which is telnet port. Okay, I'm denying the telnet traffic sourced by this destination is here. Okay, let's go with the fourth one. In the fourth step, we are using another deny statement from this host to this host. There's a missing statement in here. Maybe in here there's a 0000 as well, with an equivalent of the 80, which means HTTP port. And in the last statement, we are using an access list 100 permit IP any, and this any keyword means if you want to match all sources or all destinations, substitute the entire source or destination elements of command with keyword any. Let's go ahead with another configuration example. Create an access list that will permit this subnet for TCP sessions. Okay. Create an access list that will deny telnet sessions to actually this host, for this host. create an access list that will permit any IP traffic. Okay. Access list 101 will permit two TCP sessions from this network, from this subnet, to any destination. Okay, as you can see in here, the wildcard mask is 00015 this time for /28. Okay, /28 means 255, 255, 255 and 240. To convert this guy to a wildcard mask, we can use 000 and 55. Okay, so if we add all these guys to each other, the end result will be 255, 255, 255 and 255. Okay, in the second we are writing a deny statement. Access is 101, deny TCP from any source to the destination host, this guy, with equivalent port of 23, which means telnet. And in the third statement, we are creating an access list that will permit any IP traffic, which is access list 101, permit IP any. Here is another configuration example for you. Okay, it's saying us that block just telnet traffic coming from PC1 and going to PC2. Okay, this guy will be our source, and here will be our destination. On other one, I'm writing an extended access list. Access at 101, deny TCP host from PC1 to PC2 with equivalent of telnet. And as I told you in our first slide, we should have at least one permit statement for each access list. And I'm writing the access list 100 permit IP any, which is permitting any other traffic from different from this guy. And we are also implementing these IP addresses, this access list to the inbound direction of the Fast Ethernet 01. To verify the extended access list configuration, we can use the show access list command, as you can see, and we can display them. And we can also use show IP interface and the related interface name as well. Let's go ahead with the IP version 6 ACLs. We can just use named ACLs for the IP version 6 networks, and we have the similar logic with IP version 4 extended ACL. But in here we don't have any wildcard mask, and we are using the IP version 6 traffic filter command to apply to access list to the related interface. Here is the configuration example, and we are typing first IP version 6 access list for this time, and the name of the access list we have just named ACL for IP version 6, and we are denying one host with an IP address of this, and with an IP address of this, and this guy will be our source with the destination of this IP address, and we are permitting any other traffic. And to implement this ACL to our interface, we are using IP version 6 traffic filter command instead of using IP access group command in IPv4 ACLs.